Folks, we're back. Chapter 4, Elements and Compounds. Let's get right into it. Well, we've seen we have two general categories, metals and nonmetals. Yeah, you posted a picture that had metalloid. Remember I said deep breath, don't worry about metalloids. Metals, nonmetals. Some have luster, bright and shiny. Some aren't. The metals are part of the metal group, which are part of the metal group. Well, if you're like me and you like metal groups, then you can probably name several metal groups, right? That share some common physical and chemical properties. Distorted guitar, lots of drums, okay? Because there are always exceptions, the word most is always used, okay? But we're only going to go by the quote-unquote larger percentage. Most metal elements have luster. We've talked about luster and malleability and all that, so I'm not going to kick it again, but you should know the properties, the general physical properties of metals. Nonmetals, the exact opposite. Metals and nonmetals can appear in any of the three states of matter. Metals are usually solids, nonmetals usually liquids and gases. The noble gases, or the rare gas or inner gas elements, they're a special type of nonmetal because all of these appear in the gaseous state at room temperature. Remember our buddy helium? He has a different number of valence electrons. Remember everyone else in the noble gases has 8. Helium only has the 2 because he's special like that. They have no electrical charge. They're not easily combined with other substances to form compounds. The noble gases include the elements in the last vertical column of the periodic table of elements. And I give you this cool little picture there. Hydrogen, first element to appear in the periodic table. It's an element which is in its gaseous state at room temperature. Hydrogen atoms contain 1 proton, 1 electron, but do not normally contain neutrons. Remember, hydrogen has isotopes. When we start adding those neutrons, we start forming those isotopes. It is the smallest, lightest, and simplest element known. 1 positive, 1 negative, bam. Yep, doesn't get much more simple than that. Hydrogen is the most abundant element in the universe. It is an all-important constituent of inorganic compounds such as water, acid compounds, alkaline or basic compounds. It is also present in acid salts and base salt compounds. The word hydrogen means water former. When hydrogen molecules are combined with oxygen molecules in a chemical synthesis reaction, water molecules are formed. When hydrogen is isolated from other substances, it exists as a pair of hydrogen atoms linked together by means of a covalent bond. This form of hydrogen is called molecular hydrogen and is one of the few diatomic elements known to exist in the universe. Diatomic means it occurs naturally in a pair. Okay, so even though hydrogen by itself is 1 in 1, if it's quote-unquote in the wild, in nature, it usually is found as H2 rather than H by itself. Nascent hydrogen is when we catch it all by its single lonesome self. No, it didn't quite find another hydrogen date on OkCupid yet. Hydrogen is a positively charged element. Pure molecular hydrogen is colorless, odorless, tasteless, and although hydrogen burns, it will not support the combustion of other substances. Pure hydrogen gas can be prepared in the following ways, and it gives you a list. Know those. Hydrogen is often selected to act as a reducing agent in a chemical reaction. And a reducing agent is an element or compound capable of causing a chemical reaction, which is called the reduction. Reduction can be defined or it can happen 4 separate ways. Removal of oxygen, the addition of hydrogen, a decrease in the number of valence electrons in an atom during chemical reaction, or the gaining of electrons during a chemical reaction. Rig is useful in remembering the most important of the descriptions of reductions. Reduction is the gaining of electrons. The word oxygen means acid former. When oxygen is combined with certain inorganic elements, acid compounds are formed, and oxygen is the most abundant element on Earth. So know which is the most abundant element in the universe, and which one is the cool kid here in our ball of spinning rock. Oxygen occurs naturally as a diatomic molecule, O2. This is known as molecular oxygen. Again, if it appears as O, it's called nascent oxygen. And three oxygen atoms chemically united together by the electrification of air is called ozone, or O3. Pure oxygen is colorless, odorless, and tasteless at room temperature. And oxygen is a natural component of the air that we breathe. Oxygen will support the combustion of other substances. In fact, it is quite necessary for it, but does not burn itself. When a candle is exposed to an increasing amount of oxygen, the flame burns the string more rapidly, causing the flame to appear brighter. And you can obtain pure oxygen in a number of ways. Again, you can ask the doctor how, but it's right there. Compounds which contain oxygen are called oxides. Oxides act as an oxidizing agent in a chemical reaction with other substances, and an oxidizing agent is capable of causing a chemical reaction called oxidation. Not hard. Oxidation, oxygen. Reduction, hydrogen. Several types of oxidation. The not so fun one, the fun one, and the downright cool one. So slow oxidation, relatively low temperatures, pretty slow. Rusting of metal is slow oxidation. The turning brown of an apple is a slow oxidation. Rapid oxidation, the oxidation of a substance at a relatively high temperature. The burning of wood is an example of rapid oxidation. Rapid oxidation occurs when the kindling point of a substance is reached. The kindling point is that point at which a substance bursts into flame, producing heat and light. Rapid oxidation is commonly referred to as combustion. Spontaneous combustion, this is the cool one, the explosion caused by the unvented accumulation of heat produced by the slow oxidation of organic substances. The sudden explosion of grain silos is an example of spontaneous combustion. Other types of oxidation, decay and putrefaction. These are important terms in embalming. Decay, slow oxidation of organic matter caused by aerobic bacteria, whereas putrefaction is caused by anaerobic bacteria. Oxidation is also a concept that can be described in a number of ways. The joining of oxygen to a substance, the removal of hydrogen from a substance, the increased number of valence electrons in an atom due to a chemical reaction, or the loss of electrons during a chemical reaction. And this leads you to the acronym OIL. OIL is the loss of electrons. When you put the oxidation and reduction acronyms together, you get OIL-RIG. OIL is loss, reduction is gain. And this will help you on every true and false regarding what is lost and what is gained. During any typical chemical reaction between two organic compounds, reduction and oxidation occurs simultaneously, and this is known as a redox reaction. As one is losing, one is gaining, and vice versa. Group 7, next special kid on the block. Group 7 are the halogens, or the halogens. Halogens. I've seen so many different ways of people pronouncing it, I've just given up trying to find out which one is right. The most typical members of this group are chlorine, bromine, fluorine, and iodine. They have a number of similarities. They form salts when chemically united with metal elements. They're classified as active nonmetal elements. They've been assigned an oxidation number of -1. They occur naturally as diatomic molecules, and they are present in typical inorganic binary acid compounds. We'll see what binary acids are later. And chlorine is probably the most familiar halogen element. It is most often used as a bleaching agent, sodium hypochlorite. Nitrogen is an element that is the component of the air that we breathe, and a constituent in many organic compounds like ammonia, which we absolutely love in embalming. And nitrogen occurs in the air as a diatomic element, because it said all of these should be diatomic elements. It is part of the organic compounds such as amino acids, enzymes, and proteins, because amino acids make up proteins. Nitrogen-based organic compounds readily combine with formaldehyde to produce a decomposition-resistant substance called coagulate, which is what we form when we shoot you full of nice high-index fluid. Folks, thank you for your attention. We will see you next time.